Thanks for being here. I hope everybody is here to learn something about GitHub and security features that we have. That's my information. If you have any questions, ask me afterwards. The slides will be shared as well. You can pick them up afterwards as well. Or tweet at me at my Twitter account. That will help. I wanted to talk to you about the things I've learned about protecting your code. And with code, it really means everything that we use, pipelines, our code ourselves, our applications, our dependencies that we have. I've been giving trainings on using GitHub for a while now, and there are really some very cool features that not everybody knows about, and that's what we're trying to go through today. It starts with commit signing. We'll talk a little bit about Dependabot, security alerts, then secret scanning, and even CodeQL will come into play. But before we get started, who here is already a GitHub user? Show of hands. All right, not that many people, so that's good. Then at least we can explain some of these things. Let's start with commit signing. We're here because some of us are developers, and we see more and more these days that you see a lot of supply chain attacks. People are attacking the things that we do, the things that we build, and it starts with the things that we use in our own code. These days in our business, we're still explaining the OWASP.10, for example, to new members of the community, new developers who are just joining, and explaining them, hey, your own code might have certain vulnerabilities in it. But also the dependencies that we use. We probably don't build everything ourselves anymore. You're not making your own cryptographic libraries, I hope, and otherwise make sure that you do a really good job. We pull in packages from package managers, dependencies somewhere else. You might be building inside of a Docker container. All of those things are dependencies. And all of those things are these days attack vectors. I can inject a script somewhere that will execute whenever you install a package, for example. And we want to try to protect and minimize the risk that we have there. And it's not only about our own code, it's also about our pipelines these days. Most of the people are doing something that we call DevOps. So you have your pipelines. Most of the pipelines are versions these days, stored inside of your repository with a file, whether you're using GitHub, GitLab, Azure DevOps. Most of the time that is stored in code as well. And in the pipelines we use components from other people. If you use GitHub Actions, for example, then you're pulling in actions from the marketplace. Code that people have created that does something for you. And that can be very scary. So the first question is always, who can actually push code into my repository? Who has access? This seems really boring, but this is an important part of being aware of what is happening. And if you go to your GitHub repository under settings and then collaborators, you can find who actually has access to your repository. And hopefully it's just a couple of people, so it's manageable, or it's inside of your organization. But this could be a good starting point to figure out what can people actually do. There are multiple levels that you can give people access to, and one of them is write access, then maintainer and admin, and they can make changes in your code base, of course. Well, this is what we do. We're developers. We use we have coworkers that do this sort of stuff. But if you have a public repository, then it might be more than just that. And then the question is, well, who are those accounts and what are they actually doing? Do I know these people? And then there's, of course, two different ways that people can have access. It starts with the things that we all do in our normal day-to-day work. You have direct access, you get push something into a repository, either you're using HTTPS or SSH, depends on what you prefer. But people these days also have indirect access, especially in the open source world. If you have a public repository, then anybody can create a fork out of that, work on top of that, and send in a pull request. And in that pull request, they might change your pipelines all of a sudden. They pull in third-party packages that do certain things. That could be weird. That could be an attack vector as well. And this is straightforward. This is the stuff that we know. But inside of GitHub, you have multiple ways to give people access to things. There are deploy keys that you can give a specific repository, create a deploy key for that, install that on a machine, and then that machine can deploy to that certain, or read and write to that certain repository, for example. Machine users is what we also call service accounts or robot users. They can do the same thing as normal users can do. GitHub Apps is something special. Dependabot, you'll see that later, is a GitHub app as well. It's an app that you can install inside of your organization or repository, and it can do certain things for you, like Dependabot. We'll talk about that later as well. You can even create your own apps that do certain things with your repositories, and they can have read and write access as well. Then the GitHub token is even very specifically for GitHub Actions. The GitHub token is created whenever a actions pipeline executes. And that token by default has read and write access to your repository. Read and write. So it could do something while the workflow is being executed and change code in your repository, even the pipeline. So you need to be aware and set things up in a good way. We as developers, this is straightforward for us. This is how we push code. You configure your username and email address on the command line saying, this is me, this is my email address. And that email address is specific in here. That email address is the part that GitHub uses to actually verify who created the commits inside of your repository. Just the email address. Why am I starting here? Because it's only using that email address, not the way that you have authenticated against your repository. So when you did a git clone and you gave it your credentials, either over HTTPS or SSH, that's not the part that is being used to show inside of the UI. So all of these usernames on the left-hand side are coming by matching the email address that is linked to the commit, and they're showing you that these people probably have created these commits. Why am I starting here? Because I'm a trainer, I'm a developer, I use this specific functionality to automate commits inside of repositories. Especially during my trainings, I fake that I'm a user. I give it an email address. I can write the Git configuration or overwrite the Git configuration. Say, I am that specific user. I can use your email address, make a commit in your name, and push that into my GitHub repository. And then the GitHub happily shows your user account saying, this user has created that specific commit. Because that's what we do, of course. You say the default Git commands, I'm adding files, committed in your name. This just picks up whatever the configuration is on that end, and it starts executing on top of that. Why am I starting here? Because this is the default way that everybody is working inside of GitHub. And we can improve on that with Git commit signing. Who here, some of you use GitHub, who here uses two-factor authentication on their GitHub account? Show of hands. Who here already uses Git commit sign? Just one. You just see how insecure this is. I can make Git commits in your name. And that's where Git commit signing comes in. With Git commit signing, you use GPG keys, or you can use smime, but let's take the example of GPG keys. And GPG keys is what is normal in the Linux world. I have my private key, and I can give you the public key part, which you can use to verify my signature with. So you install it on your machine, and give GitHub the public part of your GPG key, saying whenever I sign my commits with this specific key, you can validate that it comes from me, and set that up correctly. After you've set up GPG on your machine and given GitHub the public part, you then need to start signing your commits. And you do that with an extra parameter. I want to sign this specific commit. Well, since some of you are developers, I'm one as well. I'm very lazy and I don't want to type 4 extra characters, 2 spaces and those 2 characters. So you can say git config, commit my GPG sign each and every time I make a commit. Way easier, and now you don't have to think about it. But with each commit that is signed, I'm actually digitally verifying that this comes from a machine that I have under control by setting up my GPG key that way. Sounds straightforward, so let's look at a little demo on how this works. Let's see if switching goes correctly. Ta-da. All right. Let's say, for example, I'm in my editor. I use Windows, so I have Windows Terminal open. I'm in a Git repository. Let's say we echo out Warsaw. Typing is hard. We're not in Warsaw, we're in Krakow, sorry. My mistake. So I'm making a change, of course. I can run git status. I have that in here, so I can git added. If I can type. Typing in front of an audience is always weird. And then I can say git commit special. I didn't say I want to sign it. My machine should say, hey, you should be signing this one. This can, for the first time, always take a while. It's nice that this is a big screen, so you can actually read it. I've got it here on 4K, and that's really, really small. I've set up my GPG key with an actual passphrase. You can set it up without, but then I can still make commits in your name. So please use a two-factor authentication on this as well, for example, a passphrase. So if I send in my passphrase, it will take the commit, even typing is still hard, and it will sign my commit, and then whenever I push this into my Git repository, Git can validate that it comes from me, and with that we can continue to the next step. Let's remove that. All right. So whenever I make a commit, it doesn't matter which editor I use. This works at the Git level, so it just pops up that asking for a key, that window for me. And as I said, use a passphrase there. It should be something short that you can type and can remember, that helps. But what you can also do is use a YubiKey for that. You can store your GPG key on the YubiKey. Who here has a YubiKey and uses it? Just a couple of people. It's two-factor authentication for lots of stuff. And the nice thing is that Y in the middle is an actual touch button. And with a YubiKey, that's a way to validate that I, as a person, are there. When I can set up my GPG setup where it asks for my GPG key, it knows that it needs to go to my YubiKey, and it knows that I need to touch my YubiKey physically. Two-factor authentication for your commits. You can get them, even GitHub branded ones. They're a bit pricey, 50 to 60 euros, but it really can help. And otherwise, start with just a passphrase that at least is two-factor authentication with that setup as well. The nice thing is that when you use GitHub commit signing, it still shows the username based on the email address, but then it will also show that it can verify the signatures on those commits. Or in some cases, that it cannot verify it, of course. And wherever you are in the UI with GitHub.com, it will show you that that one has a signature that was validated. So it's a huge step up, and you as the person who is using this repository can now see that you have a certain trust level, and the person that made the commits is actually the person checked by a commit signature. The next step then is Vigilant mode. It's still in beta, but if you go to your user settings and your GPG key, there's now an extra flag there that you can set. And I will say, I as a user, this is on my account level, I want everybody in the world to see my commit messages and see if they have my signature on it. Leveling up our security, or at least the things in my account as well, because now people will say that all of my commits in the UI were either verified, partially verified, or unverified. Each and everywhere where my account is visible, linked to my email address, it will show whether or not I signed that commit or not. And this even goes back in history, but only for the commits that actually were signed, and will this be visible. And we've got three different statuses there. Unverified is we don't have a signature, for example, but if you have a commit signature, it will still say unverified if it cannot verify the signature. So if I haven't uploaded my public part, it will still be, I cannot verify the signature, so it's unverified. If it can verify my signature, and it matches me as an author, only then will it show verified on all the commits that I made. And then with Vigilant mode is the next step up. That is done the next step up. So if it's not there, just because I said I want Vigilant mode on, it will show that in the UI and say, hey, this one hasn't been verified, and the author requests that we show that message then. So it's a big improvement regarding security. If you then use signed commits, you can go to the next step. Hopefully you're already using something like the two-person principle, used to be called the 4 eyes principle. But you need two people to merge something into your default branch. So you use a branch protection policy to make sure that that happens. And in the branch protection policy, you can then say, I want that all of our commits that we push into the main branch or your default branch are actually signed. And if not, they can go back into their history, fix the commits, and then push them, for example. So now you can protect your main branch or your default branch with signatures on the commits as well. It does, of course, come with a little bit of impact. You need to tell your teammates, hey, we are using this, I want to have this enforced. The only thing is you cannot enforce that you actually use two-factor authentication, that you don't use a passphrase. They can still set it up and install it without a passphrase. That's the way that the tools currently work, so that's a bit too bad. But you need to be aware of that. And anywhere you use automation, especially for the DevOps who are under us, we use a lot of automation to do certain things. For Dependabot, I'll show that in the next section as well, it will already sign it automatically. That has been set up and configured by GitHub. But if you create your own GitHub app that does something with your repository, then you need to set it up for using signatures as well, especially if you use the branch protection rule to do this as well. If you're still using personal access tokens, in my opinion, you shouldn't. They have way too much access. New stuff is coming on the way, but it's not there yet. But if you still use them, then you need to start signing your commits there as well. Otherwise, you cannot merge them back with your branch policies. And if you use code spaces, who already here uses code spaces? Who here knows what code spaces is? Jeez, all right. Code spaces is super cool stuff. It's an IDE in your browser. It's basically working on somebody else's machine in the cloud. And it loads Visual Studio for you, just running in the cloud in the browser, so you don't need to have anything installed in your machine anymore. See it as a container that you spin up, and it's awesome. I think it's still in beta, maybe alpha. It's coming out later this year. But if you have code spaces, then you need to go into your code spaces setting on GitHub and tell it that it can allow GPG verification as well. When the code space is created, it will inject a GPG key, match that to your profile under the cover, so you don't need to do anything. And it will be visible that it's a specific GPG key, and not from my machine, but from the code space itself as well. All right, so far for commit signing. Who is going to do something with this next time they're at the office? Show hands. We can improve on this, guys and girls. Improve a little bit on security. Well, then Dependabot. Dependabot is a bot, a GitHub app that you can install inside of your repositories and organizations on GitHub that does exactly what the name says. It's a bot that handles your dependencies. It can send in updates whenever there's a newer version of a dependency available. And that can greatly help and improve there. It's available for free on public repositories. Most of the features that I have here are for free, and that's why I think it's such a no-brainer. You have them, start using them. So I hope that I'm at least showing you how they work and that you think we can start implementing them. I, as a user, I really love these things. These help me as a developer as well. Because what do we see usually with dependencies that we have? In some teams, there's one person that every month in a month thinks, well, maybe I should update my dependencies. And then starts pulling in things and notices that it has been way too long, and then stuff breaks because the changes are way too large and stuff doesn't work anymore, and then maybe you don't do it anymore. We've seen organizations who created applications and never updated their stuff. Well, guess what happens these days with supply chain attacks? There will be vulnerabilities found in there. There will be new updates, things that make things better and faster and improve that. And that is why we need to pull in those updates from dependencies as much as we can. So how do you configure that? Dependabot configuration file needs to be stored in that specific location on the default branch. It needs to be in a .github folder and needs to have the name Dependabot. That's one of those magic files that GitHub has inside of their whole setup. And I was wondering once in a while how much magic there is inside of GitHub. If you go to that tiny URL, then you see that there's at least 25 different files. If you place them in the right location and name them in the right way, things will start working for you. Dependabot YAML is one of those, so it's, if you want to get an overview, check that link as well. You configure Dependabot with that file, make sure that it's merged into the default branch, and from then, Dependabot will run on a schedule. Whenever you set it up there, I've got a schedule that is an interval of weekly. You can set it on daily, weekly, and monthly. It will go through all of the dependencies that it sees inside of your repository, match that with the public version, the latest that is available on the package managers that you use. And if there's an update, they will send in a pull request for you to review, giving you an opportunity to check if those dependencies or if those updates don't break your application, verify running your tests, for example there, and then you can set it up. It supports lots of ecosystems. The most common ones are there. I'm targeting NPM here, for example, and that will mean that Dependabot will go through the manifest files for that specific ecosystem, so in this case your package.json and your log file, pick up all the dependencies that are there and match them against npm.js.org in this case. You can set up Multiple ecosystems in the same file. This is YAML based, so that's an array of ecosystems. There's lots of stuff available already. Even GitHub Actions in your pipelines is a supported ecosystem for Dependabot, and they can keep your GitHub Action versions up to date as well. All right, let's see how that works inside of a little demo. I've got an example here, but this was a static example. I saw a notification earlier this morning that worked a little bit better. This is in one more check. Oh, I thought that I had that one specifically open. No, never mind. This is an NPM JavaScript action that I even have, so it uses NPM under the covers. It can see that there are incoming changes for ES build that I use. There's a specific version that I'm using currently. It says I want to bump that to the latest version. And sending in the pull request will then show the package log JSON file was of course touched, and the package JSON file in this case. So that's everything that we can see from the pull request itself. It was made in one commit. On the commit level, you can see that we have verified the commit signature that Dependabot uses. So we clearly mark that this comes from Dependabot. In the conversation tab, you can then dive into what is happening here. Saying, hey, we want to bump that version. ES build is a public repository, and since GitHub.com has that power of the community, we can even go to that repository and see what is happening in there. But thanks to that, we can also pick up the release notes from that version that were there. Or even, these are 3, 4 versions. We can see the release notes for each and every version that was in here. Trunk is right now, usually it fits on that page. And you can really see what is actually being updated. Everything in line, so you don't have to switch to anything. We can see an entire change log for the versions that are there as well. We can even go through all of the specific commits that made this specific change set happen. So if you really want to dive in on what the hell are they doing before you start pulling in that dependency, this is a great way to learn what is happening there and dive deeper into that. You can run your test in there. So this is using GitHub Actions, verifying that everything still works. This is executing my application, see if it still works. So that gives me a good confidence score of should I be pulling in this specific update. And it's doing this for each dependency separately that you have. Yes, the next step is that it will even look into all of the open source repositories that have Dependabot configured, go to the specific version changes that are there, and this usually works if there's only a single version bump, because I'm apparently rather unique that I have multiple versions in here. That was why I was searching for a better example. But they give us a compatibility score. Dependabot knows which specific dependencies it was updating for us. And if it's open source repositories that are doing exactly the same thing, it can compare what is happening with the pull request and validate that with the thing that we're doing here. So it runs all the checks in GitHub Actions and it stores in the backend then how many times those actions failed, giving us a compatibility score saying, with this specific version update, we have this score. It's usually about above 80 to 100. And that's then green, so that gives us more confidence that we can pull in this thing without breaking anything. You still need to rely on your own tests, but it's a good way to have that. And that is why I was searching for a single version bump that usually works. Then, you can also communicate with Dependabot. It's a really nice service. And you can, for example, say, I want to ignore this specific major version. The whole ecosystems these days use semantic versioning. Who here knows what semantic versioning is? Show of hands, just a couple of people. With semantic versioning, we give meaning to each version. So if you have 1.20.40, then the 1 is the major version, and as long as that stays stable, there are no breaking changes. Then the 20 part is the minor version. That can be updated when there's new functionality available inside of the library. But it's always backwards compatible, because if we break something, then we update the major version. And the last version, in this case 40, that's just the patch version. And then you can have multiple suffixes, but they don't matter that much. In this case, so if you say we want to ignore this major version, we see that Dependabot comes in and says you need to migrate from version 1 to version 2. And you are, as a team, for example, decide we're not ready for that yet. You can tell Dependabot that. it will store that and it will not create new pull requests for new versions that are doing something between the major version bumps. You can now still say, I want to have minor version bumps for version 1 because we are still using that. And you want to pull those in because usually in those minor versions, sometimes they do it in a patch, they do also security fixes in your libraries. So you can say major version, I want to ignore that, I want to ignore the minor version, or entirely ignore this dependency. This one is scary, this update that we see, we don't want to have that as a team, so we want to stay on the latest stable version, for example, and then make a decision whenever we want to update that. So with that, you get a confidence score. It's really easy. You see that there's a lot more velocity on updating all of the security fixes because you can just get pull requests in. Be aware that by default, if you configure the Dependabot configuration file, it will only send in 5 pull requests at the same time. So whenever you close then a pull request, you'll see that it will create a new one, especially in the first time, and that can be a little bit much work. But afterwards, it's easier because it does that on a schedule. And if you have set up your test suite in such a way, minor version updates are all of a sudden no longer scary, and you keep up to date with the latest updates. Yeah? I'm not sure if you have someone with your microphone, or otherwise we can do that afterwards. Somebody's starting to run. Otherwise, just shout.
Can this Dependabot be added automatically by GitHub to some repos? Because I have some repos that I'm not using for 2-3 years, and I keep receiving notifications that a lot of packages are not up to date.
No, they're not doing this automatically for you. You can create automation yourself and start adding that file as a pull request to each repo, but that's up to you. And that's unfortunately usually the thing that we see within GitHub, is they have very nice solutions, but you need to create them.
Okay,
So
thank you.
It's too bad, but all right. I always need to check if GitHub is up because it has some issues lately. And if it's not up during a presentation, it sucks, of course. So I have some screenshots. That also then enables me to validate if I've actually told you about everything. The changelog I showed you, the commits I showed you, those commands that are pretty important. And then let's go back to the configuration file. Those commands are helpful, but it stores that on the back end, so it's not really clear to the rest of your team that you've said, I want to ignore this one. You can make this very specific in your configuration file, where you say, I want to ignore all the major version bumps for Express to 4.x and 5.x. So you do that in your configuration, and it's very clear what's happening there. You can also say, I want to entirely ignore any dependency updates for Lodash, for example. Or then just say, for the specific version of AWS SDK, I only want to have updates for anything that is a semantic versioning patch. So this way you're telling, I want to ignore any major version updates and any minor version updates. As long as the patch is revving, I want to pull in that one with a pull request, and that's fine. So you have lots of configuration options here. And you do this for each and every ecosystem that you have in there. If you, for example, have a single repository NPM for the front end, and then you have something like C# in the back end, for example, you can set it up with the same configuration file, and Dependabot will keep sending a pull request for that. You can even say the default 5 that I mentioned is not good enough. I want to have max of 20, for example. You can set it in the configuration file and tell it, give me more, which can be helpful, especially in the beginning, because when you start merging in those updates, it will just create new ones for you. All right, that's Dependabot. Who likes this stuff? Who wants to play with it? Ah, cool. It is available for free on public repositories, so it's a no-brainer. It makes your life easier. And GitHub has stats where they really say we see a huge improvement over the time span it takes in repositories for new versions to be picked up. Just be aware that it creates pull requests, and you need to be on top of your notifications to see that they're coming in. Yeah, for private repository, it is part of GitHub Advanced Security. So you need to have a GitHub Advanced Security seat to be able to enable that. All right, let's talk about security alerts, because Dependabot now knows about all the dependencies that we have. And we're getting pull requests already for version bumps. But those ecosystems also have databases that say, hey, we have a vulnerability in this specific version. So you can go to Dependabot, also again free for public repositories, because GitHub really said we want to improve the open source world. Corporations need to pay for those features in private repos, but for public repos this is free. It knows what you're using, it can check that against the database, and if there's a vulnerable version, it will send you in an alert. Sorry. You need to enable this on the repository level. It starts with Dependabot alerts, for example, and if you enable Dependabot alerts, it will also enable the dependency graph. I'll show that in the next demo. Because the dependency graph is the part that picks up your manifest files, and Dependabot then starts working with whatever's in those manifest files. So if you go to settings and code security and analysis, you can enable that one. And then, whenever something is found inside one of those repositories, as soon as that vulnerability has been logged inside of the common database, you will get an alert, like I have on this repository. It already says, hey, big banner, scary, we have found potential security vulnerabilities, go do something. Let's take a step back. If I go to this is public repository. If I go under insights and then the dependency graph, you can see what it is picking up from all the manifest files. So in here I've got a to-do list application and a playground one that has manifest files that it is picking up. And you can see that I have for my to-do list application more than 1,000 dependencies already. Especially on NPM, of course, we know that this is really turtles all the way down. This is, for example, a library that I'm using in this to-do list application. It does something useful for me. It is a popular one because it has 27,000 stars, so that's a good one. But this is the dependency that I have a direct mention of a version number in my manifest file. Well, you probably know that in these package managers, we see a whole slew of packages that have a dependency on packages. And guess what happens? Those packages have dependencies on packages. And those have packages and packages. This is usually you can click for a couple of minutes before you finally find something that doesn't have any dependencies anymore. The Facebook regenerator doesn't have any stuff in here. So we build on the shoulders on top of giants, as we always say. We're not building and reinventing the wheel ourselves. We use a package manager. And this is what the community does, of course, as well. They build on top of other packages as well. And if anywhere in this whole tree there is an issue, I might have an issue in my application. So this is why the supply chain is so important. We need to be aware of what is happening there. And what our actual dependencies are. We call the dependencies over the dependencies transient dependencies. So they're not direct dependencies that you are dependent on, but they're dependencies of your dependencies. So if you have that set up, you can actually go to Dependabot alerts. It's under security, it's only visible if you're the repository owner. Then you can go to security and then you can see that we have Dependabot alerts. From those 1,000 dependencies that we're pulling in, I already have 52 alerts with specific levels of how critical it is. So let's open the first one. It will tell us what the security updates are, how we could, for example, update it to the latest version. Usually these things are fixed with responsible disclosure, where the person who found the issue told the maintainer, so the maintainer could fix it, bring out a new version and say we have a vulnerability, but it is fixed in a newer version. It gives some bit more information. Since this thing is open source, you can usually go to that repository and read more. But what I want to point out is the critical vulnerability security score, the CVSS. That's a score that is calculated on how easy it is to misuse that vulnerability. In this case, this attack vector comes from somewhere in the network, so you don't need to have access to this specific machine. It comes from somewhere in the network of where you're hosting your application. It's very low in complexity, and you don't need any elevated privileges to access this one, and you don't need user interaction, mostly. In this case, it does. With that whole setup, they calculate that security score. In this case, it's super high. It's on a score from 0 to 10. This one is critical. You should fix it immediately. It's probably even, you can misuse this one just by going to a URL in your web application, if you have set it up in the way that this specific vulnerability works. Then, there are links in here to the common weaknesses enumeration database. So this is very helpful for us as developers to learn how this stuff actually works. Why is this an attack vector? What is the vulnerability? What is happening there? It could be something like a path traversal attacks that we've seen, or a regular expression that can DDoS your application server, stuff like that. Super interesting what is here. Most of it is stored on Mitra. You can go there with the link and read more on that. That's a weakness enumeration that will have an ID. There's also a common vulnerability enumeration ID in the database itself. So that's a specific vulnerability for that specific library. You can go to that and learn more. But these days, GitHub has their own security advisory database, where they have an extra layer on top of those security advisories. And that has an ID as well. You can go there, open it up. This is this specific CVE that we have in that specific package. And it will give us more information, more risk references, even back to the NIST database of the American government that can really help. The attack vectors are here again, so we can learn tons of stuff in here. Link back to the repository. And the nice thing is that it knows about all of the repositories that I can see. So it tells me we found this vulnerability in one of your repositories, that's how we got here. But it also says you've got 183 more alerts that all have the same package used. So especially if you have a CISO in your organization, this is super insightful information for them as well to see what do we have. We all had that question in January, are we using Log4j? Or insert anything that was vulnerable in the last half year. This is a way to give us a single pane of glass to get that information on top of all of the repositories that we have. That's a good starting point then. The nice thing is that that advisory database is open source. You can contribute to that. They've backfilled that with all the vulnerabilities that they found interesting until 2017 or something. And it used to be a nice even split between what they have reviewed, in this case 7,000 advisories, and the things that they don't have reviewed yet. There's an actual team of human specialists going through this list, usually focusing on the high-level risks that are in there, and actually validating if that vulnerability is there. We have seen cases where somebody reported a vulnerability and the maintainer of the repository said, well, yeah, if you do it in a very specific way, yes, but we're not using it in that way. We can prove that this vulnerability is not there in this situation. And then GitHub advisory database can annotate that specific vulnerability and say, well, we agree with the maintainer, we've actually done some due diligence to verify this, and it's not a vulnerability in our mind, giving you less and less of sort of false positives that you need to stick work in and do certain things with. But you can see there is still a huge backlog of things they need to go through. But that's a good point. Different systems that show, for example, the common vulnerability enumerations that will just say you have something there and it might be disputed by the maintainer. And they stop there because they don't have their own version of the database. And I put my trust in GitHub then because they have a very cool team that is really going through these things, debating if it should be a lesser risk, for example, helping us as community members as well. All right. I'm not sure how we're doing regarding time. We should still have time. That is found potential security fixes. I've shown you the overview as well. If you're an organization owner and you have the security access there, you can even do this for your entire organization. So that's very helpful as well. I've shown you how to enable Dependabot alerts. You can also do that for security updates. So getting the alert is step one. Getting then the security updates as actual pull requests to your application is step two. You can decide as a team if you actually want that as well, but I recommend enabling that as soon as possible, especially for public repositories. And those pull requests look exactly the same as Dependabot we've seen, except for that big header on top that says, hey, this one fixes a security vulnerability. It gives you the scoring setup in here as well, so that can be a good starting point saying, I'll go through all my pull requests, this is the one we fix first. And if you set up your DevOps setup in such a way, you can immediately push that through to production. You can also see the compatibility score here. So this could be a thing where you say, well, we actually need to verify that everything is still working. And hopefully you have a test suite, test in your test suite somewhere that does that for you, but otherwise you need to put a human on it and validate if stuff still works. So that's the compatibility score. As soon as it drops under 80, it will turn orange, and under 50, I think it's red. All right, I've shown you the vulnerabilities as well, so that is that part. Let's go over to secret scanning. Secret scanning is the third part in what they call advanced security. If you have a GitHub enterprise account, for example, then advanced security is part of that. Dependabot is the first, secret scanning is the second, and CodeQL is the third. But all of these are available for public repositories for free. Why? Well, probably you have had this as well. You have accidentally committed a secret into your repository. And hopefully it was just a benevolent secret, but this has happened with production connection strings on my end. Direct connection strings to a production database in the cloud. Oops. So having secrets inside of your repository is a big issue. It's really, I cannot fathom that people still have this, but we see that people just inject secrets into issues, pull request comments that they give each other, Jira tickets, whatever. But those secrets could contain things to our cloud environment, for example. So secrets have a high risk and we need to do something about it. Well, this functionality is enabled by default on public repositories because GitHub has seen that it has a very low noise level, so most of the things they detect as secret really work. It's an actual secret. And they want to improve the community and the whole stance of all the public repositories because we're all in this together. It's enabled by default, but you cannot even disable it. That's how important GitHub thinks this feature is. They currently have over 70 secret scanning partners. And the most important ones are all there. All the major cloud providers are there. Anything that generates an API token, most of them are already there. But if you do that as a company, you can join that as a secret scanning partner as well. Even Discord, you can generate API tokens for that and do something. That's available as a secret scanning partner for this as well. Well, how does this work? It starts with you as a user accidentally, hopefully, committing a secret. You do a git add and all the files are there and then you just push it. It gets pushed over to the server side, in this case github.com. GitHub will store that information inside of your repository, and if that's a public repository, then it could be already available for the public internet. We've seen people actively hunting commits on public repositories specifically for these secrets, because they could run a Bitcoin miner on your Amazon environment. They could have access into your blob storage environments. And read access is interesting these days. We can get information from that, download it, and say, haha, I've got your data, please pay up. It is stored inside of the repository. GitHub then runs the secret regular expression patterns. If you are a secret scanning partner, then you can say, this is a regular expression that can match my secrets. This is why you see a huge uptake in industries actually making sure that you can recognize the secret. GitHub is, for example, doing that by prefixing their secrets with GHP for GitHub Personal Access Token, and then an underscore, and then the rest of the 16 hexadecimal hash. So they can actually pick up, this is a secret and it comes from that specific cloud provider, for example. If it's a hit, they will send it to a verification endpoint. Secured, hashed, one way, and sending, hey, we found this and your regular expression says that it's yours. Can you please verify this? Then it's up to the secret provider what it does with that, but they have an endpoint somewhere to receive those requests with. They can do the checks on their backend, and depending on the secret provider, they might say, oh, this is an actual secret of us. Please alert the user and say, hey, you have pushed a secret into your repository. You probably don't want to do that. Revoke your secrets as soon as you can. Some secret providers go a step further and say, oh, this is scary. This is a real-life secret. For example, your personal access token on GitHub. GitHub has said, well, that's scary. We immediately revoke that thing and send you a notification saying, hey, you've got a secret in your repository. Don't do it, we've revoked it for you. It depends on the secret scanning partner if they actually implemented it that way. You can imagine that there's discussions there if this is your actual connection string to your production database and they will revoke it for you out of a service and all of a sudden your webshop is down. Some people might not like that. But then again, it's already there, so it should be on you to, as soon as possible, revoke that thing and rotate it. All right. If you enable that on a private repository, then it will immediately start running. And it scans your entire history of your repository. Because, especially for public repo, of course, it could be stored anywhere, in a branch, in something that is tagged. It doesn't have to be on your default branch. And currently it runs after pushing to your repository, the first time when you enable it, and then after each push it will run and scan for you. Scanning issues, comments, and pull requests is on the roadmap. I think it's somewhere at the end of the year, because that has high vulnerability options, of course, as well. And people are actually sharing secrets inside of those things as well. As I said, if it's a actionable secret, it's up to the partner to decide what they want to do. But if it's a public repository, it's a very good probability that they will revoke it. I've seen this happen with SQL Server connection strings on Azure, for example. GitHub does that. GitHub has bought NPM, of course, so now NPM is ramping up their security as well, so they will revoke that for that as well. And I've got an example for that in this repository. This one is private, but that shouldn't matter that much. If I go to my security settings, we can see that I have Dependabot alerts that we shown earlier. We got code scanning alerts, that's up next. And we got secret scanning alerts. This is, of course, a demo repository for a training that we used, and it found an Azure storage account key. I can go into that alert, see who made a commit, for example. It was detected 9 months ago, but this is for demo purposes, so I still have it open. And it already tells us, be aware that this secret is already compromised. It is stored inside of a repository. That repository could be stored anywhere inside of pipelines, for example, where you execute it. You cannot trust it anymore. It's inside of your repository. Treat it as compromised, revoke it, rotate it, do something with it. This was found in an app settings file, so probably somebody accidentally configured that, and it detected that with the regular expression, finding out that there's an actual account key in here that could be used to do something with against the storage account here. So this is something that we should fix. You can say this is coming from an app settings.development. So we only use this for local desktop, for example. So this is only something that works in a local container. It cannot be executed from anywhere else. So we could dismiss this one as saying, hey, this is a false positive, or we use this in a test. It will be stored in the backend with a date and time when the person who did this, saying, hey, we don't use this anymore, and any time secret scanning runs and still picks up this secret, it will check that with the specific status and saying, I won't report it again. So that's very beneficial. I've already had this at least a dozen of times that it found something in my code and, oh shit, that's in there. We need to fix that. So it's a big improvement that you can actually improve that here. One extra thing that they've built, and this is not available in the public version, so that's a bit sad, but it's still so cool that I wanted to have this in here to show you, is be aware that this runs after receiving all of the data on GitHub side. They've already stored it, and if it's in a public repository, anybody can already see this. I've actually had mails from other providers that do these kinds of services saying, hey, we scanned that public repository of yours and we found a secret. Maybe you want to buy our services to improve this and not let this happen again. So they're actively searching for these. This is a paid feature, but it is in there. And push protection, you can enable that on the repository as well, or even the organization. It will scan it before ever storing that data. So whenever you do a git push, it will scan all the incoming changes. That goes blazingly fast with all those regular expressions that they run even. And if they find a hit, they immediately say, we don't accept the push. Give it back to the developer saying, hey, you need to fix your commits, otherwise we cannot store this. There are then still ways to go to the UI and say this one is okay to use, but this stops it even before storing that. So you can even get an alert on the command line where you said, hey, I did a git push. It will say, we reject this push because we found this secret in that file and that specific commit, go fix it. So this is where you probably want to be as a user, in my opinion, but it is a paid feature. Who wants to start using these things? It's available for free, you can start using it. It's a huge improvement over probably what you currently have, and that's probably not that much. All right. We're almost there, I think we're going time. CodeQL, let's power through this one. CodeQL stands for Code Query Language. And with queries, we're developers, we know that there's a database involved and you run queries against it. This runs on top of GitHub Actions. This is an example of an action that we call, where we say we want to initialize the database and start working on it. And if you then have a code base that it needs to be compiled, for example, you compile your code afterwards, it will pick it up and it will build up a database of all the traversal paths in your code. Saying method A is calling method B, sending in this parameter, that parameter is then converted into a constant, for example, and sent into the next method. And that way we can build up a graph database of what is happening inside of your code. And if we have a database, then we can actually run queries against it. And if the queries return results, we make CodeQL alerts out of it. So with the analysis step in your pipeline, it will actually run all the queries. You can tell it which queries to run. There's a whole slew of them. There's even now an experimental set where they use machine learning on the OWASP top 10 to automatically run all the queries for that and find out if you have vulnerabilities from that top 10. Available for free on public repositories. There's CLI support. There's a container that you can use to do that locally, for example. So if you want to develop your own queries, you can do that. It currently has support for these 7 languages. So that's already available. It runs on action minutes, and if you have a public repository, currently you have unlimited action minutes, so it runs for free. Small demo. If I go into my repository, I've got a pipeline in here that runs the CodeQL queries, and then under security, I can go to code scanning alerts and see that it found an issue with the level of high. Apparently I'm clear text logging sensitive information. Well, we of course know that we shouldn't do that. There's a whole slew of common weaknesses in here that you can learn more about. It will tell us which branch it found this on and the severity here. And apparently we're logging a profile to the console in here. Okay, that's a good starting point. It gives us a bit of information of which specific query that found this issue. We can do show more and find out the recommendations, for example. Here's an example of what you should not be doing, and then an example of an improvement on there. A whole slew of literature to learn more about what is happening in here. But the interesting part is in top. It says we're using an app password somewhere, and that gets stored in this profile. And that is what we log out to the logs. And then the most interesting part is actually show paths. I said it's a graph database. It picks up all the traversals through your code. And this is exactly what it shows us. There are 12 steps in the provision composer. We start out with an app password. So that is the entry point of the sensitive data. Since this is a password, it's probably sensitive, so it picks that up. There's a couple of times that the same issue comes up. But that app password then gets morphed into a create result constant. Somewhere later in the same file. Then the create result again, it's in here twice. It then is sent into a method somewhere. So it's transforming again. Then it is converted into a profile constant, where the settings are being stored with create results in there. And then you can already see it here on the line, but it shows us on the next step saying, hey, we are stringifying the profile, and we log that into the logs as clear text because we haven't annotated that password as being sensitive data. This is a short example of the things that people have wrote queries for against your path database. And it found it, told us, hey, there's an issue here, you should fix it. You get a notification, and it's up then to you to fix it. So this is an example of what CodeQL can do for you. One last thing before we start wrapping up, because I don't think we have enough time anymore. CodeQL is actually open source. It's a repository, you can go there. You can learn from the community. You can see that we have 200 open pull requests. So apparently this community is very active. There's lots of security researchers who are diving onto this, creating queries, wanting to be the one that says, I now have a query that will tell you if you have vulnerability X in your software. So it's a good starting point to learn more. You can find the queries per language in here. So in C# under QL, you find the things that they have there with a specific source. For example, I'm a C# developer, so if I go into bad practices, there's a file here with the example of why you shouldn't use unmanaged code. There's the fix part that you will see in the UI, and then there's a query that is actually a query. So we can see that we're importing a specific language pack, and then we write a query. We want to have information about the classes that we use, the methods that are there, and the calls on the methods. And if the methods are external and the declaring type is a class and the target is something else, then hey, we're doing this with unmanaged code and you shouldn't be doing this. You get an alert from this query on your code base and you have something to fix. It's another big step in improving our security stance, and this is a super active community. If you go into insights, and then this already here. This is just the last week. 46 pull requests closed, 41 are still open. And if you do this over a month, then it's even more. And it's lots of people who are contributing there. So it's a very active community. You can use this for free on your public GitHub repositories. For me, it's a cool feature and it's a no-brainer to start using it. All right, since I think we're out of time, I showed you the demo part. These were the topics that we had. Who's going to work on these? Start looking into that. If you want to get the slides on the links in here, scan this QR code. If you have any questions, let's do that offline, because I think the next speaker is already waiting for us to close off. You can find lots of more information on my blog. I really like to document these, even just for myself. So if you want to know more about GitHub security features, the magic files are there. Figure that out. And if you have questions, just pop them afterwards. Thank you.